Chapter 4, Section 2, Integral Exponents, Master. So again, we're just doing more simplifying. Things are just getting a little bit more complicated, but we're going to rely on everything that we've seen before. So I have x to the negative 3 over y to the negative 1. So the only difference is in this video, I have negative exponents appearing in both the numerator and the denominator. Okay, well, you have a choice. You can deal with them one at a time, or you can deal with them all at once. It's up to you. So in this example, I'm going to do them separately. So I'm going to leave the x to the minus 3 up here just for now, and I'm only going to focus on this. So therefore, that becomes y to the positive 1, and there's an invisible 1 there. But now I can focus on the x, so this becomes y to the 1 over x to the positive 3. So with this in the denominator, I no longer need this 1. Okay, but I hope you could see that really all I did is I just swapped them. Okay, so both of them had negative exponents, so by reversing their positions, their exponents became positive. So you could have just as easily gone from here to here in one step. This part here was not necessary. What if I have a fraction? 2 over 4 to the power of negative 3. Well, let's look to BEDMAS. Okay, remember, we always simplify what's in the brackets first if we can, and we can do that. 2 over 4, that is the same as 1/2. But again, that entire thing is still being raised to the power of negative 3. Okay. Now we've seen before what happens when we have a fraction being raised to an exponent. All it means is we have the numerator and the denominator being raised to that same number, negative 3, separately. Well, now I can treat this example just like this one over here. Okay, they just swap. So this becomes 1 cubed down here, and this at the bottom becomes 2 cubed up here. But I can work this out. 2 cubed is 8. 1 cubed is just 1. So 8 over 1 is just 8. This is just an aside if you want a shortcut. If you find this a bit confusing or just too much to deal with at once, don't worry about it. But if you have a fraction that's being raised to a number that is negative, in this case negative 3, there's a quick trick that you can apply. And that is, you just take the reciprocal of whatever is inside the brackets, as is, and then you can reverse the sign of the exponent. So I'll put that up here. So you don't have to worry about this if you feel it's a little overwhelmed. Okay, so 2 over 4, I'm not going to reduce that just yet, I'm just going to show you the flip. This becomes 4 over 2, and now the whole thing is raised to the positive 3. 4 over 2 reduces to 2 cubed. And of course that is 8. Right? So I get the same result. The reason why I don't teach this right off the bat is I found in the past that kids just get confused. There are just too many different rules to remember. So I like to stick with the basics. But if you're comfortable using this relationship, by all means go for it. Let's try another one. So I have a bunch of negative exponents in both the numerator and the denominator, and numbers everywhere else. So 3 over 20, I can't reduce that, so I'm stuck there. This has a negative exponent, so does this. Again, watch your brackets. So I'm just going to shift around everything that I need. So this 20 is still there. This y to the negative 2, that can come down here. And then the 2x to the negative 2 can go up here. And there we go. So let's just try and tidy this up a bit. This is 3 times 2x all squared is 4x squared. And this is still over 20 y squared. So you can start reducing now if you want, or you can multiply and then reduce. Doesn't really matter. Numbers are small anyway. This is 12x squared over 20y squared, but 12 over 20 is reducible. Okay, they're both divisible by 4. So this would give me 3x squared over 5y squared. Next, x to the negative 3 over 3y squared, all in brackets, being raised to the power of negative 1. Okay. Now, there's more than one way of simplifying this. Okay. You might wish to do something differently than what I would do. As long as what you do is mathematically correct, no problem. So, but what I am going to do, however, is stick to BEDMAS. So I'm going to work out everything I can in the brackets first, and then I'll deal with this. So if I'm sticking to the inside of the brackets, that means this negative 1 is still here. I haven't dealt with that yet. Okay. The 3y squared in the denominator, that's no problem. However, this can go into the denominator, leaving a 1 still here. So this is 3y squared times x cubed. Okay. And I'll just rewrite this as 3x cubed y squared. Now it's in alphabetical order. Okay, now what? Well, this entire fraction is being raised to the power of negative 1, which means the numerator is being raised to that power, and so is this one. Okay. Oh boy. How on earth do we deal with this? Well, we can apply a switch. Okay, this can go to the denominator, and then this entire thing can go to the numerator. Okay, so this becomes 3x cubed y squared to the positive 1, and then this becomes 1 to the positive 1. Now anything to the power of positive 1 is just itself, so I don't even need these dumb things anymore. And anything divided by 1, of course, is itself. So my final answer actually is 3x cubed y squared. That's it. Okay. I'm going to demo this problem one more time over here, and I'll do it in red. But I just want to show you that that there's more than one way of getting to the same answer. Right? So what I'm going to do is I'm actually going to apply that shortcut trick that I showed you earlier that you don't have to worry about if you don't like it. So if I have a fraction here and the fraction is being raised to some number that's negative, I can just reverse the sign of this and take the reciprocal of everything that's inside. But here's where you have to be very, very careful. So if you don't like this method, you find it too confusing, don't worry about it. Okay? So this is going to become positive 1, and all I do is I take the reciprocal of everything in here as is, so I don't start changing the sign of this exponent. Okay? So this becomes x to the minus 3 over 3y squared. Okay? But now, anything to the power of 1 is itself, so I no longer need that 1. Okay? And then I can quickly take care of this x to the minus 3 by removing it from the denominator and putting it in the numerator. Of course, that would leave an invisible 1 in the denominator, which I don't need to write. So here, I'll just split this off here. Okay, so I get the exact same answer. Okay, just be careful with this method. Again, if you don't like it, stick to what you know. All right, this next example looks pretty ridiculous. Okay, I'll give you that. But I would hope you could recognize this part right here. I have PQR over ST, whatever that is. But notice how it's being raised to the power of 0. Well, what did I say about anything being raised to the power of 0, except for 0? That's just 1. So this entire thing is just 1. And this times 1 is just itself. So that's exactly the same as this. Okay. I just effectively dropped it because this times 1 is just itself. So all I have to do is focus on simplifying this mess here. Well, from here on in, there's actually quite a number of different options for you. Okay, we can take this x to the minus 3 and shift it to the denominator. Okay, and then we can apply this negative 2 to the numerator and the denominator separately and then start flipping those. That's an option. What I'm going to do, however, is this. Okay, we know that when we have a fraction being raised to some exponent, whether it's positive or negative, these rules still apply. That's the same as just raising top and bottom separately. So this is yz to the 4th. But then I have to raise this entire thing to the power of negative 2. Okay, this is just a different option. But whenever I have a double exponent here, you just multiply, which is what I have there. So this gives me x to the positive 6 divided by yz in brackets to the power of negative 8. There we go. So this power here can shift to the numerator. Leaving an invisible 1 in the denominator. But again, everything inside this set of brackets is being raised to the power of 8. So this is just x to the 6th, y to the 8th, z to the 8th. Finally, we're done.